what we're going to do is we're going to take a look at the role of h in y equals x minus h squared. So here's what we're going to do. We're going to recall something that we studied just before. So remember, when we first started our lesson today, we actually took a look at this thing here. We went and calculated our values for -3 all the way down to x equals 4 for y equals x squared. Right? Now, because we did that, that just gives us the basis for our graph, doesn't it? So when we look at y equals x squared, I'm going to explain what we're actually talking about here. Just put those numbers in. And then what we're going to do is we're going to see what happens when we punch in x minus 1. And you'll notice that for each of these grayed out graphs, we're not going to go and calculate the x value, sorry, the y values for these things. We're only going to calculate for the unshaded boxes. Okay? So now let's do y equals x squared. Now if we use Desmos to calculate those tables, we would have gotten that. So now what we're going to do is we're going to jump over to Desmos and we're going to punch in this graph, this equation right here. We're going to find out all the x values for this. Punch in the x values and get the y values for x equals -2 to x equals 4. Let's see what happens. Now, in order to compute this, remember we have to use everything on the right side of our equation in our box for y. So now we're just going to raise that to the power of 2, and we're going to go and calculate from -2 all the way to +3. Oops, I said +4. And you'll notice when you punch this last number in, you end up with exactly the same numbers for our y values in y equals x squared. The only issue is we have shifted everything. We've shifted all the x values to the right exactly one spot. So right now what I'm going to do is I'm going to ask you guys to go and pause the video and graph the y equals x squared box. Then I want you to graph the y equals x minus 1 squared graph, and let's see what comes up. So here we have our y equals x squared graph. So as you can see, once we've graphed our lines, what happens is that x squared, when it turns into x minus 1, what's happened is every point in our graph has actually shifted, literally shifted to the right by 1 space on our graph. So what do you think would happen when we have x minus 3 squared? Let's see. Punch those values into Desmos, and remember you're going from x is 0 to +6 in our table. Now, in computing this thing, we end up with exactly the same result as what we did before once we punch our stuff into Desmos. Now let's get back to our graphing. So now we filled out our table, and now what I need you to do is I need you to graph this again. And you'll notice something kind of peculiar. So now what happens is when we have x minus 3 squared, it literally took the image of y equals x squared, the blue line that we have here, and shifted all of the points to the right exactly 3 spots. Okay? So now what I'd like you to do is I'd like you to take a look at the graph y equals x minus 6 squared and tell me, what do you think it would look like based on the base image of y equals x squared? could you tell me what actually happens? And now let's go take a look at it. Try to make that prediction, then we'll go and do it up in Desmos. So now let's create the base image of our graph by actually getting Desmos to just generate the graph for us. So we have y equals x squared, which is this graph here, our base image. So now I'd like to know what you guys think the new image will look like. So when we did this before, we took a look at our work, and basically what happened was every time we looked at our graph, every time we did x minus 1, it shifted the graph over to the right one. When we did x minus 3 inside our bracket, we ended up with x minus 3 being a parabola that was identical to the first one but shifted to the right by 3. If you guessed that your graph, the graph of x minus 6 squared, moved to the right 6 units, then you are correct. It's an identical graph. It's just translated to the right 6 units. So the new word translate talks about taking a base image and moving the image either right or left, up or down, or a combination of those two. So if I was taking a look at y equals x squared minus 6, to use the word translate in a sentence to describe what happens with x squared minus 6, we would say the following. We would say that the graph y equals x squared has been translated to the right 6 units in order to get x minus 6 all squared. So now let's get back to our Desmos problem. Our problem that we're doing. So for this problem, y equals bracket x minus 6 squared, what you're going to say is, you would say this graph has moved to the right 6 units. So let's write that in. So we would say that the graph y equals x squared is translated right 6. And we're good. So the key is, if it's x minus 6 all squared, or x minus 9 all squared, it's moving, the graph has moved to the right. So now let's do this next one here. This should be pretty interesting. Let's do this graph here. We're only going to do for y equals x squared. We'll copy down what we had from before into here and begin. So we'll just fill out the y equals x squared graph. So we have our base graph. We will graph it on our chart. So as always, we're always going to start with our basic graph, our base image of y equals x squared. And now we have to figure out what happens when we have x plus 2 squared. So in this chart for x plus 2, we're going to do our calculations in Desmos, and we'll see what we come up. So now let's go and put in our graph. Remember that our graph must have bracket x plus 2. Our brackets must be around what we have, and then we square it, and we get this. So now let's see what happens. So we're going to go from -5 to positive, let's see, 4 to 1. And notice that is what our graph looks like. Now let's go and put the original equation for our graph down. Let's not use that. We're going to use this. So we're going to put in an expression, and we write y equals x squared. So that was our original graph, y equals x squared, and I'll change that to a nice blue. Then let us go and graph the image graph, the final graph. So when we graph that point, graph that other parabola through those points, we should have something that looks like this. So what's happened is when we're looking at this problem, this point here, our vertex here started at 0, 0, right? And then we go over to this other point, its corresponding point has been shifted to the left exactly 2 points. So if it says x plus 2 inside our bracket, I think of it as opposite world. If it says x plus 2, we move to the left exactly 2 spots for every point in our graph. And the base point for our graph is always 0, 0. And we will eventually use those steps that we created a while back in order to understand how to graph these things very quickly. So now let's go back to our sheet and fill out the rest of our problem set. Now just take a moment, fill out your chart. I'm going to make this one black. So I got 9, 4, 1, 0, 1, 4, and 9 again. Plot your points and tell me what your graph looks like. And we get something that looks like this once we've graphed it. Now, what do you think is going to happen with y equals x plus 4 squared? If you think that this was going to be our values for our table, you're correct. And so now we have this. So when we have x plus 4 inside our bracket, we've moved our vertex over to the left exactly 4 spots. So now, if I take a look at y equals x plus 7 squared, I want you to take a look at that, and I want you to predict what will happen. I'm not going to do it, but pause the video, come up with a solution, go take a look at it in Desmos, and then come back here. Okay, so once you've done that, you would have realized that this graph, literally this new graph of y equals x plus 7 squared, really would be a translation of y equals x squared left 7 units. So x plus in the bracket means the stuff moves to the left. X minus in the bracket means the stuff moves to the right. So now let us summarize what we have here for our final answer. So we'll just make a quick correction to my sheet here. So basically, how does the value of h in this equation, y equals x minus h all squared, change in y equals x squared? So here's the deal. If h was positive, then you would have something that kind of looks like this. Example, y is equal to x minus 3 squared. So you'd have the opposite of what, because you know, if I had a negative and a positive, I get a negative. So x minus 3. So this tells us it moves right. Our graph moves right. So now if h is a negative value, think of a negative value. A negative of a negative gives me positive. So we get y is equal to x, say, plus, say, 4 squared. So what does it move? This thing moves to the left. So all of the points in our base graph y equals x squared will move either to the left or to the right, depending on whether h is positive or h is negative. So in your work that you're doing, just take a look at the actual equation and don't worry about what h is. We will figure that out later in the next lesson when we pull all this stuff together. So now we're going to end up going to the next video, which talks about moving parabolas up and down.